So I'm Ariel Onbar from Arizona State University. So I'm a geochemist, and geochemists think about rocks as made up of chemical elements. And we have various tools that we use to be able to tell what rocks are made of. So for example, this tool here, this is a X-ray fluorescence tool that we can use in the field actually. We can point this at a rock and get a measurement of what its elemental abundance is, of what the elements are that make up that rock. And in this location, for example, if I were to point this tool at these rocks down here, I'd find that there's a lot of calcium in them because these are calcium carbonate rocks. And that's true of the rocks above me here as well. These are also calcium carbonate rocks. But there are other types of rocks that have different elemental abundances. So for example, in the layer in here, you can see that this looks a little bit different, and it is quite different. It's a clay layer. And if I were to analyze the chemical elements in here, I'd find that there's not nearly as much calcium. There's a lot of aluminum though, and silicon, and elements like titanium. And so by looking at the chemistry of the rocks, we can learn a lot about what they are. Now, this is just one type of tool. We have many different types of analytical tools in geochemistry for studying rocks. And those tools can let us measure the abundances of all sorts of elements, including elements that are much, much rarer than common elements like calcium or silicon or aluminum. So elements, for example, like iridium, which is very rare at the Earth's surface, but is abundant, we think, in the Earth's core, and also we know is abundant in meteorites. So I couldn't do it with this tool, but with the right kind of tool, right kind of instrument, if I took a sample of this boundary clay to a lab and analyzed it, I'd find that this boundary clay is very enriched in the chemical element iridium, which is an element that's very rare at the Earth's surface. And in fact, there's so much iridium in this clay that the scientists who discovered it really puzzled to try to explain how there could be that high a concentration in this thin boundary clay. And the only explanation that they could come up with is that that iridium came from a large meteorite impact, an asteroid impact, at about 65 million years ago, at the time of the extinction of the dinosaurs. And it was the discovery of that enrichment of iridium here that was the foundation for the idea that the extinction of the dinosaurs and the other biological changes that happened at that time were triggered by an asteroid impact.